Hi, in this video I would like to explain how the binomial theorem relates to Pascal's triangle and what a factorial is. So first of all, let's take a look at an example. Suppose we wanted to take a short little quiz with 4 questions, and we wanted to know how many ways we can get one question wrong from this quiz. So what we are looking for is the combination. There's many ways we can get one question wrong. How many ways exactly? Let's take a look. So for example, for this quiz, I could get question 1 correct, get question 2 correct, get question 3 correct, and I will get question 4 correct. And this will give me 3 out of 4. But there's other ways I can get 3 out of 4. For example, let's try a different combination. I could get number 4 correct, number 3 correct, number 2 correct, and get the first one wrong. And that will also give me 3 out of 4. Using the same idea, we can get question number 2 wrong and get the other 3 correct. Or we can get question 3 wrong and get the other 3 correct. So in each case, we have 3 out of 4 correct. Now, in how many ways can we get one question wrong from this quiz? So we can see that if looking at my combinations, there's 4 different ways we can get 3 out of 4. So 4 different ways we can get 3 out of 4. Now, when it's a small sample size, in this case, since we have 4 questions, our sample size is just n equals 4. So we can easily do this by hand and see the different combinations. Now, what do the combinations mean? Well, let's take a look above here. When we're looking at the binomial theorem, this part right here is the part of our combinations. That is the coefficient. That is how many ways your probability can occur. Sometimes the k can be written as x. So here it is, means n combination x. What does that mean? It means n factorial all over x factorial n minus x factorial. Now this is a formula. You don't need to memorize this. What does n factorial mean, for example? Well, 5 factorial just means 5 times 4 times 3 times 2 times 1. Now what does the factorial mean? The factorial means how many ways can I rearrange something that has 5 items, okay? And in the same way, how many ways can I rearrange 4 items? And how many ways can we arrange 3 items? So every time you plug it into the formula, you can get your combinations. So for example, we wanted to know in how many ways we can get one question wrong from a quiz that has 4 questions. So I can use this and say, well, from 4 questions, in other words, my sample size 4, in how many ways can I get 1 incorrect? So using this and plugging it into this formula, we can say 4 factorial all over 1 factorial times n minus x, in this case 4 minus 1, which is 3 factorial. Now simplifying this, we see right here that 4 factorial is the same as 4 times 3 times 2 times 1, which is 24. And 1 factorial is just 1, and 3 factorial is 3 times 2 times 1, which is 6. 24 divided by 6 is 4. So we can use this formula to rearrange to see in how many ways we can get an item to be rearranged. Now, in this case, as I mentioned before, since our sample size was 4, it's easy to do this by hand. But once your sample size gets a little bit bigger, such as 5, or even 6 or higher, then it becomes a little bit more tedious to work it out. Now, how does the Pascal's triangle relate to this? Well, Pascal's triangle right here, if you remember last class, I mentioned every row starts with a 1 and ends with a 1. So the first one right here, this is called row 0. And 1, 1 is row 1. And I can go on forever listing this, but you can see that if my 2 is in my row, that's row 2. This is row 3, row 4, row 5, and so on. So actually, Pascal's triangle helps you find the combination part of your binomial theorem, which is this part right here. So in other words, I can also go to the fourth row, since my sample size is 4, and I want to know how I can get one question wrong. So if I went to my fourth row right here, now the item also starts with 0. So this is the 0 item, first item, second, third, and fourth. So I can see that this 4 right here actually represents, this is row 4, C1, first item, whereas this one represents 4C and the 0 item. Now you can actually, you don't need to work these by hand, but any combination I'm looking for, I just need to look down the rows, and you could see as I get, my sample size gets larger, I have a lot more combinations. Now let's look at the calculator, how we can work out combinations. So for example, since we already did 4C1 and we know that equals 4, we looked at Pascal's triangle and we could see that it's 4 in this position. We also used the formula and got 4. Now I'll show you how to use the calculator, and we will also get 4 when we enter for combination 1. So let's go ahead to the calculator. To get to your combinations, you just go to menu, go to probability, and under combination number 3, click that, and you will see NCR. So all you need to do to enter your N and your R is you enter it as your first is your N, and then put a comma and 1 in this case. So we should get that 4C1 is equal to 4. So your calculator can easily work that out for you.